Yeah, in the last session, I have explained what a modulus function is and how to sketch a graph. Now, in this session, I will explain inequalities involving the modulus sign. So here, I will explain some useful rules, okay, um, that can be applied with inequalities and modulus sign. So the first rule is that the absolute value of x is equal to the absolute value of minus x. I hope you've seen that in the previous session when for example, the absolute value of 5 is equal to the absolute value of what? Minus 5. Then a minus b, the absolute value of a minus b is equal to the absolute value of b minus a. What does that imply? If I have, let's say 5 minus 3, the value of 5 minus 3 is what? Is the absolute value of 2, which is equal to 2. The absolute value of 3 minus 5 is equal to the absolute value of minus 2, which is also equal to 2. So that implies that a minus the absolute value of a minus b is equal to the absolute value of b minus a. The other thing you should note is that the absolute value of x squared is equal to x squared, because absolute value of 4 squared is also 4 squared, and absolute value of minus 4 squared is also 4 squared. It doesn't matter. A negative does not matter. And also, if then another rule is if the absolute value of a is equal to absolute value of b, then a squared is equal to b squared. This is another one. If the absolute value of a is equal to absolute value of b, then a squared is equal to b squared. So an example is, let's take for example, if the absolute value of 3 is equal to the absolute value of minus 3, then 3 squared is equal to minus 3 squared. 3 squared is 9, minus 3 squared is also 9. Okay, now the next one, if the absolute value of a, or let me say, if the absolute value of x is less than or equal to a, if the absolute value of x is less than or equal to a, this implies that minus a is less than or equal to x is less than or equal to a. So that means x is greater than or equal to minus a, and x is less than or equal to a. Okay, and likewise, if the absolute value of a is less than a, this implies that minus a is less than x is less than a as well. Now, the last rule. The last rule states, now finally, if the absolute value of x is greater than a, so this, implies that x is less than minus a, or x is greater than a. Also, if the absolute value of x is greater than or equal to a, this implies that x is less than or equal to minus a, or x is greater than or equal to a. So let's solve some examples on this. Okay, the absolute value of x plus 3 is less than or equal to 4. So recall that the absolute value of x less than or equal to a, this implies that minus a, or let me write it, you can also write it as minus a less than or equal to x less than or equal to a, or write it that x greater than or equal to minus a and x less than or equal to a. Both are the same. Okay, so anyone you are comfortable with is the one you should use. I hope this is understood. So use anyone you are comfortable with. Some students are comfortable with this, some are comfortable with this. Now, so let me solve this problem. Don't forget that whatever you have in your absolute value is this. It does not have to do with, does not necessarily mean to be 1x. Whatever is in the absolute value. So that means I can write this as minus 4 less than or equal to x plus 3 less than or equal to 4. okay? Or for the sake of convenience, I can write it as x greater than or equal to, sorry, not x. So I can write it as x plus 3 greater than or equal to minus 4. Because it will be minus 4 less than or equal to x. That means x is greater than or equal to minus 4. Or x plus 3 is less than or equal to 4. I hope this is understood. So if that is the case, so at this point, I can write that x is greater than or equal to minus 4 minus 3, okay? Or x is less than or equal to 4 minus 3. Those is normal linear algebra. So x is greater than or equal to minus 7, or x is less than or equal to 1, which is correct. And you can rewrite this as x, you can rewrite this as, since x is greater than 7, minus 7, that means minus 7 is less than or equal to x, less than or equal to 1, because x is less than or equal to 1, and minus 7 is less than or equal to x, because x is more than minus 7. Okay? In layman terms, if A is more than B, that means B is less than A. So that was why I just applied there in this expression. I hope this is understood. So let's solve another example. The absolute value of 2x minus 1 greater than 9. So recall that the absolute value of x greater than A, this implies that x is less than minus A, or x is greater than A. Okay, from the rule I gave you earlier. So when we have absolute value of 2x minus 1 greater than A, that greater than 9, rather, not A, greater than 9, that means that 2x minus 1 less than minus 9, or 2x minus 1 greater than 9. Is this understood? 2x minus 1 less than minus 9, or 2x minus 1 greater than 9. So that implies that 2x is less than minus 9 plus 1, or 2x is greater than 9 plus 1. Okay? So 2x is less than minus 8, or 2x is greater than 10. So that implies that x is greater than minus 8 over 2, or x is greater than 10 over 2. So which implies that x is greater than, less than what? Minus 4, or x is greater than 5. I hope this is understood. So now, next example. So I also have 5 minus x minus 2 greater than 1. Okay, greater than 1. So to do this, let me take 5 to the other side first. So I can have minus x minus 2 greater than 1 minus 5. Okay, so that is minus x minus 2 greater than minus 4. So inequality, if you guys have studied inequality before now, we can multiply minus by both sides. If you multiply minus by both sides, that will cancel out this minus, but we affect the inequality sign. Okay, so you can revise your inequality functions if you are forgotten. So that means I can have this as absolute value of x minus 2 less than 4, because I'll multiply minus to both sides. So whenever you are multiplying minus to both sides of inequality, or you are dividing minus to both sides of inequality functions, that will affect the inequality sign. So you have to note that. So we have x minus 2 less than 4. Okay, so if you remember this, this is less than, so that implies that x minus 2, okay, less than minus 4, or, oh, this is x minus 4. So this implies that x minus 2 greater than minus 4, or x minus 2 less than 4, isn't it? So from the previous rules I gave to you. So that implies that x greater than minus 4 plus 2, or x less than 4 plus 2. That means x greater than minus 2, okay, or x less than 6. So writing it together, this becomes minus 2 less than x less than 6. I hope this is well understood. Okay, see you in the next session.